Hello, good afternoon, everyone.
Good afternoon.
Am I audible?
Yes, sir, completely.
Am I audible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. Thank you, Kusum, for giving me an opportunity to talk on exploratory data analytics. Okay, so I'm sharing my screen. So is this screen visible to all of you?
Yes, sir. It is visible.
Hello, is it visible?
Yes, sir. It is visible.
Yes, sir.
Okay, fine. So, first of all, I'll talk about what is the need of exploratory data analytics. Okay. And then I'll start with first this famous dialogue, necessity is the mother of invention. So if you see with the perspective of data analytics, so we started our journey from data processing. And then we moved to information processing. Then we moved to knowledge processing. And then we talked about intelligent processing. So let's understand with the help of example, what are these data processing, information processing, knowledge processing, and intelligent processing. So you can see this computer. This is one of the oldest computer. And you can just think about what is the size of this computer is huge. And initially, we were using this computer for what are the purposes? Initially, the purpose used to be managing a set of records in an organization. And managing a set of records means what? Searching a record, deleting a record, inserting a record, or modification of a record. So if you say, let's say you have changed your residential residence, so you would like to inform your organization that now my new residential address is this. So correspondingly, that information will be updated. So that was the initial things that we used to do with the help of this computer. And now we are doing all this with the help of our small computer that you can say our mobile. We are maintaining a phone book of our friends, okay, which maintains records of our friends. We can store names, we can store mobile number, email address, residential address, and other fields. And then we can search, insert, delete, and modify. Okay, so you see that you were initially having a huge computer, and now the same thing can be done with the help of a mobile. But then, after using this successfully for data processing, then we thought of that what more can be done. And then we moved to another area, that is information processing. So what is information processing? Say you want to predict what will be the rainfall. What is the amount of rainfall on May 3rd, 2024? But this data is not available in your database. But what you can do, based on the past records of last many years, you can predict, you can develop a model which can tell what will be the rainfall, estimated rainfall on this particular day. So you see that only day before yesterday, Meteorological Department announced that in this North India, Central India, so there will be your rainfall, okay, and the wind velocity will be around 35 kilometers to 40 kilometers per hour. And you found that this came to be true. Okay, so based on the data, if you can predict some information, then that will come under information processing. So let's say you want to predict what will be the population of India by 2040. So this data is again not available. But based on the past data of the population of various years, we can see what is the change every year. And on the basis of this, it can be estimated what will be the population of India by 2040. So similarly, again, predicting GDP of a country, predicting price of a share. So if something is not available, but based on the past records, if you can predict, then that will fall into the area of information processing. But then again, we moved one level up, and then we started talking about knowledge processing. So what is knowledge processing? So we talk about, say, Lord Buddha, Lord Mahavir, Guru Nanak Ji has given some knowledge about the life. So they have, after many years of, you can say, meditations, they found that this is the truth. This is the knowledge. So among the information, you want to find out a information which was not known earlier and which can be interesting, which can be useful. Okay. So when you do this part, means information is novel, interesting, useful, then that information becomes knowledge. So if you talk about buying behavior of customers, so you'll agree that when we go and buy bread, most often we buy butter. Most often. I'm not saying that we always buy, but when we buy bread, many times we buy butter. So we can see that these two items are bought together quite often. So similarly, when we buy potato, we buy onion or tomato. Okay. Similarly, when I buy shirt for myself, in general, we purchase new trouser also, matching trouser. So when we go and purchase pulses, in general, we purchase rice. So these are the items which are bought together. So I'll explain that how, now why we'll say it's knowledge. So for this, I'm sharing another interesting story. And this is a true story. In one of the grocery shop in US, manager wanted to improve the sale. So he thought that in what way I can improve the sale. So they apply different techniques, give discounts, offer some schemes, so sale will improve. So similarly, he thought that what are the two items which are bought by a customer, but which is not known to them, so that if they can find out such items, they can place on the shelf at the nearby location. So if somebody is going to buy item A, and then B can also be bought by that person, by that customer. So he appointed one data analyst that you can analyze our last many years of transactions of different customers. And then if you can find out, you can tell us that which two items are bought, which are not known to us. So after analysis of the data, he informed that the person who are buying diapers, I think you all must be remembering the spelling of diapers. Huh? So the persons who are buying diapers, which diapers are usually used for small children, and we use when we go for weekend program somewhere, move from one city to another city. So the persons who are buying diapers, they are buying beer also. So then it was very surprising that this diaper is for small children, and this beer is definitely not for small children. So why these two items are bought together? So on further analysis, they found, oh, these two items are bought during weekends. So many of us who were buying diapers during the weekend, because in general, when we buy diapers, it is for weekend program. So then they thought that we can buy beer for ourselves, just for fun. So based on this knowledge, self was rearranged and found that sale has improved. So can you see what is the difference between information processing and knowledge processing? You have the data, huge data, and from the data, you are taking out information. If that information is known to you, okay, then it is information. But if that knowledge is new to you and it is interesting, it can be useful to scientific community, to the society, okay, to the medical community, then we say that is your knowledge. So then we have not stopped here also. Then we started talking about, so you can see next time you should not be surprised, okay? So then we move to intelligent processing. Means the way we process, based on the data we process, we come out with some better solution. So similarly, machine can also behave like human intelligently. So now you see that if you want to take some intelligent decision, okay, so how it is different from knowledge processing? So I give you again an example. Think about that if you have a refrigerator and while leaving for your office, you look into your refrigerator and found some vegetables are missing, okay, or milk is not in enough quantity, okay, or fruits are not available. Then what you do? While coming back from your office, you purchase those items or you place online order these days, okay? But now instead of this, you talk about Internet of Things. Through sensors embedded in your refrigerator, it can be estimated amount of milk, the quantity of vegetables, different kind of vegetables or fruits. And if one particular item is not available or one or more items are not available, so refrigerator will be directly placing the order to the grocery shop, but bill will be paid by you. Okay, so you see that a machine is able to take decision intelligently, just like humans. So these days you find that we are talking about automatic cars. There are many features which are now automatic. You don't have to change the gear. Now you may think about in near future, you have a driverless car. Okay. So all these are examples of intelligent processing. So when you are talking about these are the basic different kind of processing you do, and the data is coming from various sources. So the data can be, let's say there is a railway system, they are generating lot of data. You talk about automotive, aeronautics, retail shop, finance, logistics, internet, health management, medical devices. So all of them are generating lot of data. And from these data, you want to take informed decision. Okay. So we talk about data analytics. Okay. So when you are talking about data, so what you are saying, you have a large chunk of data and you want to process this data to take informed decision. Okay. So what kind of decision you can take? So then you can talk about descriptive analysis. So from the data, you want to go deep into the data and you want to find out what happened based on the data. Or a particular event has taken place, why did it happen? Okay. Then we talk about diagnostic. Okay. When you want to predict, as I said in my earlier example, you want to predict what is the amount of rainfall, what will happen. Okay. Or prescriptive, that what should be done. So let's say you have a surveillance system. It is continuously taking recording data. And if some, you can say, event is happening, which is not desired, so system can raise an alarm. Okay. Or let's say you have many embedded sensors in your body, and based on some kind of pattern, let's say your heartbeat is more, or a pulse rate is more. So it can raise an alarm, or it can send some kind of information to your home doctor, okay? Doctor to whom which you regularly visit. So you see that from the data, you can do various kind of things, descriptive, diagnostics, predictive, prescriptives, for taking informed decision. And from the data, for taking informed decision, there are various steps are involved. Okay. Initially, you collect the data through various means. The data can be in some files. The data can be from images, videos, audios. Data can be collected from various sensors, or you already have some data which is in your database. Okay. But then these data may have certain kind of noise. So before you develop any one of the decision model, it is important that you should be able to remove the noise. Or let's say some of the fields are missing. Then it is important that you should be able to do some kind of pre-processing. Okay. Or you find that the data is described in terms of many features, many attributes, many fields. Okay. Then in certain cases, it is important that you reduce the data. So we talk about dimensional reductions. Okay. So all we can say that these will come under your pre-processing the data. And finally, based on this pre-processed data, you develop predictive models or data analytics models. And once your decision model is ready, then you integrate with the system, and then you take online, you can do online predictions. Okay. So then where is your, when you talk about data analytics, what is your data, exploratory data analytics? How exploratory data analytics is different from your data analytics? So I will say that exploratory data analytics will help you in carrying out meaningful analysis of the data or meaningful prediction of the data or meaningful description of the data. Okay. So then what is EDA? Okay. So we can say the analysis of data based on various numerical methods and graphical tools, okay, is said to be your exploratory data analytics. So when you do analysis of the data based on various numerical methods and graphical tools, then we say it is your exploratory data analytics. And what you do under this? So you explore the data for finding out meaningful pattern, interesting patterns, to find out trends, to find out underlying structure, okay, or hidden structure, and deviation from the trend, or you say anomaly. So by exploring data, you are going to look for finding out interesting patterns, some kind of trend, that okay, the price of the share is keep on going down. So based on this exploratory data, you can see okay, there is a clear trend. We see that for last 5 months the price of the share is keep on going down. Okay. But then you also see based on some kind of past data that after you can say fall in the prices of the share, then again it will start increasing. Also, there can be some kind of cyclic pattern. Okay, so there is some your effect of season. Okay, so that's what you do in your EDA. So it facilitates discovering unexpected as well as confirming the expected. Okay, so there is another definition also of EDA. What is that? An approach philosophy for data analysis that employs a variety of techniques and mostly graphical. Okay, so this is another definition given by one of us. Okay, and if you talk about John W. Tukey, so he's considered to be the father of exploratory data analysis, because while he was working at Bell Labs in the 60s, okay, he was the first person who suggested techniques for visualizing and summarizing techniques. So there is a book by John W. Tukey also. The name of this book is Exploratory Data Analysis. Okay. So you will find that it has described various kind of methods in this particular book. So what is the aim of exploratory data analysis? First, to maximize insight into a data set. Okay, means more visibility. You find out which are the fields, which are the attributes, which are actually responsible for one particular problem. Okay. So another aim of the EDA is uncover underlying structure or hidden structure. The third is you find out important variables. Say, let's say you want to find out that if a person is suffering from cancer, breast cancer, let's say. So what are those important variables in terms of which you will be able to find out whether the person is suffering from this disease or not? So then what are those features? So in general, you may have seen that when somebody visits a doctor to find out whether he or she is suffering from breast cancer, then doctor suggests that let's go for mammography. Okay. So after mammography, what the doctor looks into, is there any dense tissue? Okay. Then what is the size of that tissue? That is nodes? What is the shape of that dense node? Or what kind of fluid is present in that dense node? So on the basis of various characteristics, okay, the doctor is able to find out whether the person is suffering from that disease or not. And sometimes when you find that this no meaningful information is coming from mammography, then they may suggest that you may have to go for ultrasound or maybe MRI. And in some cases, what happens, even these three doesn't help, and finally you have to go for biopsy. So in a given problem, so there is always a need to find out what are those important variables with the help of which you can find out that, okay, these are the variables responsible for this particular problem. Okay. Then let's say if you want to find out why the price of one particular commodity increase. So you can easily see that one important factor can be what? Price of the diesel. Because at the moment there is an increase of the diesel price, so you'll find that it will affect the transportation cost. Or let's say what happens that the price of that particular commodity, okay, so minimum price has been increased. So let's say initially it was 7,000 rupees per quintal of one particular item, and now it has been revised to 8,000. So definitely the price will increase of that particular item. So you collect the data, and then based on that data, each data is described in terms of many fields, or say many attributes or many features. But then there should be a way by which you should be able to find out important variables. And then what is the another objective of exploratory data analytics? To detect outliers, anomalies. Okay. So let me give you an example of this. So let's say in general, near your house, there is a normal, you can say people are walking, talking, moving around. But then it was noticed that there is one person who keeps on taking round, and that person is not in your neighborhood. That does not reside in your neighborhood. So this is different from the normal, because you know who are the people who are in your neighborhood, who move around in your neighborhood areas. But if you find somebody and who is the new, and moving around your society a couple of times, then it may raise a suspicious that what is the reason why he's moving around. Okay. So you find that these are the ways by which you can find out outliers, anomalies in the system. Okay. Then what is the another aim of the EDA? So you have some assumptions you want to test whether that assumption is true or false. And then once you are able to find out important variables, then you develop decision models. Okay. And in this process, you are able to find out what are the factors which are responsible for that disease. Okay. So the aim of the EDA, if you talk about, the goal of EDA is to open-mindedly explore the data. Means before you develop any predictive model, decision model, okay, or descriptive models, it is important that you look into the data and you try to explore this data without any biasness. Okay. Okay. So as per Tukey, so what Tukey has described, EDA is a detective work. Means unless detective finds the clues, judge or jury has nothing to consider. Because in the law, in the court of law, okay, your judges rely on your rules and your, what you will say, proof. Okay, you talk about some kind of supportory document before they can take a decision. Okay. Now, here judge or jury is considered to be a confirmatory data analysis, while you're finding out clues. Okay, we talk about it your EDA. Okay, so confirmatory data analysis goes further assessing the strength of the evidence. Okay, so with EDA, we can examine the data and try to understand the meaning of variables and also finding out important variables attributes. Okay. So let's see the difference between exploratory data analytics and confirmatory data analysis. So when you talk about EDA, there's no hypothesis. Initially, don't consider any kind of hypothesis. But when you talk about confirmatory data analysis, you always start with some hypothesis. Let's take an example. That is, you say that the probability of your lung cancer increases for people who smokes too often. So this is, and the persons who don't smoke, the probability of suffering from lung cancer is less. So you can assume this kind of hypothesis in CDA, but in the case of EDA, we are not talking about. We are trying to look into each one of the attribute, okay, and then find out whether that data, that attribute or field or feature is important, relevant or not. EDA allows you to generate hypotheses. Based on exploratory data analysis, you find that it looks that there is some kind of relationship between variable X1 and X5. So then based on that, you create some kind of hypothesis. While EDA, you have already started with some hypothesis. You are going to simply test whether the null hypothesis is true or not. In EDA, in general, we use graphical methods, while in confirmatory data analysis, we use statistical model. Okay. So what are the steps of EDA? After you are given a data, so after looking into each one of the variable, correlation between the variables carefully, you generate some good research questions. Okay. And for this, there is a need that you should restructure your data. Means that you may need to make new variables from the existing ones, which we talk about feature construction or feature engineering. Okay. And based on the research questions, we use appropriate graphical tools and obtain descriptive statistics. Okay. And then try to identify confounding variables, interaction between variables, relations between the variables, okay? And to find out if there any feature or more than one feature which has missing observation, then how to handle those missing data, okay? Okay. So after EDA, then you go for confirmatory data analysis, okay? So let us see, when you talk about EDA, so how EDA can be further categorized. So in general, when you talk about exploratory data analysis, so we say that the method you use for EDA either can be non-graphical or graphical, okay? So this is one way by which you categorize the methods used in exploratory data analysis. And what is the another way? The another way is that whether you are using tools, methods for analyzing single variable, then it is your univariate data methods. If you are trying to analyze more than two or more than two variables, you are trying to analyze the relationship between these, then you are talking about multivariate data analysis, okay? So when you talk about non-graphical methods, so in general, you give some kind of statistics of the data, and those statistics can be what is the mean of the data, what is the median of the data, your mode of the data, standard deviation, minimum value, maximum value, interquartile, percentile. So all these things are used for summarizing the data, okay? So as I have already said, what is univariate method? When you are looking at one variable, one feature or one attribute at a time, then you are using univariate method. While when you are using, you are trying to analyze the relationship between two or more variables, then you are using multivariate method, okay? So, but what is suggested, that is always good that first you go for univariate EDA, and then you decide go for multivariate EDA. So let's talk about non-graphical methods. So as I have said, summary statistics, okay, are numbers that summarize properties of the data, okay? So those summary can be defined in terms of mean of the data, frequency of the data, standard deviation of the data, minimum value, maximum value, range, interquartile, okay? Why? Because I can show you an example where you are given a data, they are given two data, and mean of the data of D1 and D2 both are same. So let's take an example. So if I have data, and the data is your 0, 5, 10. So what is the average of the three? So average of 3 will be what? This 0, 5, 10 will be what? 15 divided by 3, that is 5. But if you talk about another example, 5, 5, 5. Again, the mean of this is 5. You take another example, you are given a data having value 4, 5, 6. Again, the mean is same. So can you see that you have different data, but the mean value remains the same? So mean is not the only summarized information which will help you to analyze the data. But what you can see, the standard deviation in the three cases will be different. So in first case, we have considered 0, 5, 10. I think you can write down. If you have the notebook in front of you, you can write down. So first data is 0, 5, 10. Have you written? Let's say I give this D1, data D1. 0, 5, 10. Have you written? Hello, at least one of you can speak.
Yes, sir.
Okay. Now let's consider another data. 555. Now think about third data. It is 456. So do you agree that for all the three kinds of data set, mean value will be 5?
Yes, sir.
Okay. But if you compute standard deviation, so what is the standard deviation of the first case? For first case is a 0 minus 5 whole square plus 5 minus 5 whole square, 10 minus 5 whole square divided by 3. So it is what? 25 plus 0 plus 25, 50, 50 by divided by 3, which turns out to be equal to how much? It is your 16.66. Yes or no? Okay.
Yes, sir.
But what about second case? The data was 555. Standard deviation or variance, whatever you say, standard deviation is your square root of variance. So initially I have computed your variance. So if you compute variance of the second data, what is that? 5 minus 5 whole
0.
square plus 5 minus 5 whole square plus 5 minus 5 whole square divided by 3. So standard deviation is 0. For third data, what you see? 4, 5, 6. Mean is 5. So variance is what? 4 minus 5 whole square plus 5 minus 5 whole square plus 6 minus 5 whole square. And it turns out to be equal to how much? 2 by 3. 2 by 3 is equal to how much? That is 0.66. So can you see? The mean of the three data is same, but standard your variance of these three are different. Hello?
Yes, sir.
Can you see this?
Yes, sir. Yes.
Similarly, I can show you certain examples where mean is also same, mode is also same, and your median is also same. Okay. So if you talk about if it is your normal distributed data, you will find all the three mean, median, mode will turns out to be same. It is same. And you also may find that your mean of the two data is same, standard deviation is also same. So then you look for some other variables, another summarized quantity, which can help you to analyze. So then we talk about your second order moment, third order moment, fourth order moment, kurtosis, skewness, and there are many things which we describe. There are different, these are different statistics for analyzing the data. Another quantity, another thing which I talked about is what? Frequency and mode. So if you are given a data, and let's say that data is described in terms of 5 attributes. So what you can do? You can describe frequency of an attribute value for that particular attribute. So you want to find out how much time this value, let's say A1 is occurring in that field. So that we talk about percentage. So let's take an example. In general, if you take any random samples, you will find in most of the situation that the your gender population is around 50%. Okay. Now, there is another summarized quantity which we talk about mode. So what is mode? Mode is what is that attribute value which is occurring most often, So for this, what you do? You find out frequency of each one of the attribute value, and then you find out which attribute value has maximum frequency. So that will define mode. Okay. And similarly, we can define median. What is median? You can arrange the data in ascending order. So we'll see later. Okay. So similarly, there is another summarized quantity which we use, that is percentile. And in general, this is used for continuous data. So what is percentile? So if you are given an, I will discuss what are these type of variables. Okay. So the variables of the data can also be a different type. One is your field is taking continuous values, say height of a person. Okay, so it will take continuous values. You can record that reading in terms of meters and centimeters. So you talk about, let's say, weight. So this is also continuous value. So one of the attribute can be your continuous. Then there is another kind of attribute which we talk about, binary variable or binary attribute. What do you mean by binary attribute? It can take only two values, yes or no. So example, say doctor asks you, do you have cough? So your answer will be either yes or no. So they will ask, are you married? So then you say either yes or no. So you find that in some of the cases, a variable can take only two values. Then such variables are said to be what? Binary variables. But then you also have other kind of attributes, and which we talk about category. And these category variables are not taking continuous values. So let's talk about metals. So you have different kind of metals. You have gold, you have silver, you have bronze, you have brass. Okay. So they will come under what? Categorical variables. Now in categorical variables can also further be divided into two categories. One is your ordinal, another is your non-ordinal. Okay. What do you mean by ordinal? Means when you can order the values. If you have some, you say ordinal variable. So if you can order them, let's take an example. So let's say if you are given a particular attribute and it has colors. You talk about red, green, and blue. Can you order them? No. Because I cannot say red is more than green or red is less than blue. But when you talk about, let's say, gold, silver. So here you can order them because you know the price of the gold is more than the price of the silver. Okay. Or let's say you have given grades. Now you have got some grades. So in those grades are, let's say, A, B, C, D, E, F. So what we usually know that A is the highest grade. B is the second highest grade. So again, you can order these grades. So if categorical variables, if it can be ordered in one particular form, then we say it is your ordinal variable. Okay. So so now when we define percentile, we define percentile for an ordinal attribute or for continuous attribute. So let's say you are given an attribute X. Okay. And there is a number P, which is between 0 to 100. So what is your P percentile? PH percentile, it will be represented by XP. And this XP is what? P percentage of the observed value of X are less than XP. Okay. So that's how you define. So what you can do, you can arrange the values of the variables X in one particular order. Okay. And then if you are saying 50%, if you say X 50%, what does this mean? It means that 50% of all values of X are less than X50. So, so I think you all must be knowing what is mean. So mean is nothing but if you are given a data having values X1, X2, X3, Xn, and you want to find out what is the mean value of the data. So what you do, you sum X1, X2, X3, Xn and divide by n. That will give you mean value. But what is noted is that in general, mean is very sensitive to noise or outliers. So means there is one value among the data which is very large in comparison to other data, or very small in comparison to other data, then this will give rise to outlier or noise. Okay, so mean is very sensitive to outlier. Okay, then what is done? in that case, what we do, we compute trimmed mean. So what do you mean by trimmed mean? So what we can do, we can eliminate first, we can order the data, arrange in ascending order, and we eliminate, let's say, first three samples, and we have eliminated last three samples. And then we computed mean of the remaining data. So then we say we are using trimmed mean. Another way is that instead of computing mean, you can compute median of the data. So what is median? Given the data, you arrange the data in ascending order. And if you consider there are m data, m number of samples, then you can find out if m is odd. So what you can do? So let's say I talk about m is equal to 5. So 5 can be written as 2 into r plus 1, means that is what? 2 into 2 plus 1. So xr plus 1 is going to be the median. So it is a middle point of the data. So if you are going to have 51 samples, then definitely you see that x26 is the median of the data if you arrange them in ascending order. But if the number of samples in the data is even, then what you do? So let's say you have 10 samples. Then what you do? You compute mean of x5 and x6. So that is going to be the median of the data. Okay. Now, similarly, what is the another statistics this can be used? You find out maximum of the attribute value and minimum of the attribute value. Okay, maximum of the attribute value and minimum of the attribute value, and then you just take the difference between max and mean. Okay, so then that is your nothing but range. Okay, so range is also used as one of the statistics to describe the data. Variance is another one. Okay, and if you are able to know the data x1, x2, x3, xn, how you compute variance? You compute the mean, then you subtract each sample from the mean, take the square, add them together, and divide by n minus 1. In some sometimes you use 1 by n, another is your 1 by n minus 1. So when you use 1 by n minus 1, we say it is your sample mean. Okay, sample variance. Okay. But however, this variance is also considered to be sensitive to outliers. Then what is suggested is that if you can compute absolute average deviation. Absolute average deviation. So how you compute? Compute the average. From each sample, you subtract the average and take the absolute value. And then of these absolute value, find out the average. So then we say it is your your absolute average deviation. Then you have median absolute deviation. Median absolute deviation. So your first step will be same as AAD. Then after finding this absolute difference with respect to mean, then you find out median of this data. Then one very commonly used in range is what? Interquartile range. And this is defined in terms of what? X 75% minus X 25%. And as we have discussed, what do you mean by X 75%? Means 75% of the samples in the data is less. Okay, as you see, we have seen what is your this. So we say when we say P% of the observed values of X are less than XP. So if you are saying X 75%, it means what? 75% of the samples will have value less than X 75. And similarly, you can compute X 25. So the difference between these two will give you interquartile range. No. But you will find that visualization techniques are more oftenly used okay, for the analysis of data. So let us see what we do in visualization. So what visualization is? Conversion of data into a visual or tabular form You say bar chart, pie chart, histogram, so that the characteristics of the data and the relationship among the data items can be analyzed. Okay. And visualization of the data is considered to be one of the very, very important component for exploratory data analysis. Okay. And when we talk about humans, so humans has the capability of analyzing large amount of data visually. But in general, we can analyze two variables data. But at the moment the number of variables increases more than 2, so it becomes difficult for us to analyze. But yes, if we can take those n variables data and show it graphically, okay, then we can find out different kind of patterns and trends. We can detect outliers or unusual patterns. So you just see this. So this diagram or this image shows the sea surface temperature for July 1982. So can you see that this we are showing the data of the whole world, and this is telling you the range of temperature. Means you are showing that if the color is of this, color is this in the map, then the temperature is around 30 degrees. While if the color is this, then the temperature is around minus 10 degrees. Well, if the color is somewhere around like this, then the temperature is around minus 15 degrees. So you are able to see through one image how the temperature is varying across the whole globe. So you see there is some kind of pattern. Can you see that this is the region which is almost red, means it has high temperature. And what is this region? This region is your tropical region, yes or no? Equator, okay? Sorry, equator is, this is the region, this is the where the equator is passing. And as we move away from the equator, on both the side, you find the temperature decreases. So you can, through one image itself, you are able to analyze how the temperature is varying across different countries of the world. Okay. Now, so while you show such kind of images or tables or your different histogram, so what is important point is representation. Okay. So it is the mapping of information to a visual format. So what you do, you have various data objects which are described in terms of attributes and which also has some kind of relationship among these objects. So basically you show such kind of relationship in terms of a graph, okay, where each data object or data samples can be represented in terms of points, lines, shapes, or colors. Okay. So in general, when you will see graphically, you'll find that samples or objects are represented as points, and there are attributes, values can be represented as position of points. Okay. Attribute values will be representing where is that point is located, and then what it can be described in terms of color also. It can also describe size. It can describe shape. Okay. So I said that in general, when we do exploratory data analysis, the data is huge. Means the number of samples are also too many, and the number of attributes, number of fields, number of variables are also too many. So then it is important that you should be able to find out attributes which are not relevant. Or you say it is important that you should find out attributes which are relevant. So we talk about selection of relevant attributes. Selection of a subset of relevant attributes. And this will help you to reduce the data. So the moment you are able to reduce the data, so when you will be doing, when you will be developing predictive models or decision models, then the complexity of that model will also get reduced. Okay. So today, while I'll be showing you demonstration in our lab class, I'll be talking about this particular data, which is very small, and the number of attributes are only 4. Okay, so there was one researcher and who was analyzing iris plant data. So that's why the name of this data is iris data. So this is found in your European region. So that researcher has collected 150 samples of this iris flower. And basically there were 3 kinds of flowers. And those 3 flowers were Setosa, Virginica, and versicolor. And each one of these flower is described in terms of 4 attributes, 4 features. And those features are sepal width and sepal length, petal width, and petal length. Okay. So today we'll work on this data. Okay. And we will see how we'll be using exploratory data analysis for this. But just to show you at present in this session, so let's say you have 4 samples, 4 attributes: sepal length, sepal width, petal length, and petal width. So what you can do, so let's say for petal width, you want to draw a histogram. So what histogram will help you? What histogram will give you the information? What it will give you? 1 minute. So you can see that I have drawn this histogram where there are petal width takes various values among these 150 samples. So it is showing the frequency of each one of the values. Okay. So if the value is lying between 0 to 0.25, what is the frequency? When the value is between 0.25 to 0.5, what is the frequency? Similarly, 0.5 to 0.75, what is the frequency? Okay. So this tells you, by analyzing this, can you see that most of the flowers has petal width of the range between, so you say 0 to 0.25. Okay. So at present, I have shown histogram with 10 bins and 20 bins. Okay. So using different number of bins, you can analyze and then you find out. So you can see that which value of the petal width has more frequency, and that will help you in analyzing further the data. So with the help of this histogram, what you are showing usually show the distribution of values of a single variable. At present, we have shown how the data is distributed for different values. And for showing this, what we do? We divide the range of these values into many bins. And then you count how many of the samples falls in that bins. And that is the number of the frequency, the count associated with that range. So the height of each bar indicates the number of samples, number of objects which are there in the database of that range. And this will give you the, so this shape of the histogram will depend upon the number of bins. You can see that when I changing, so the shape is little bit get changed. Okay, but overall trend remains the same. So as we have discussed histogram for univariate, we can also plot histogram for 2 features also at a time. Okay, so here we have shown that the 2 variables are petal width and petal length, and we are counting that for this petal width and this petal length, what is the number of samples lying in this database. Another important thing which was given by Tukey. Tukey was the one who has given the concept of box plot, and we can plot a box plot of a single variable, and you will get something like this, where this red line in this square box tells you 50th percentile or say median value. Okay, And this lower blue marks gives you that 25 percentile, 25th percentile, means the number of samples having attribute less than this value is this much. Okay, how many of them are taking values less than this? This is your X75. Okay, this is your 100th percentile, and this is your outlier. Okay, so I have we'll do it practically after this session. So for the Irish data, I have shown the box plot. Can you see that for sepal length, what is the median value of the sepal length? It's somewhere around 5.75. Okay, and this is what? This is your median, or you say 50th percentile, or this is your what? 25th percentile. This is your 75th percentile, and this is your 100th percentile. Well, for sepal widths, this is the box plot. For petal length, for this is this. So from this, what one more thing you can analyze? There is less spread in the values among sepal width, and there is more spread in the petal lengths among the samples. Can you feel this? Can you have such inference from this box plot that among the samples for sepal width, the variation in the sepal width among 150 sample is less, while the variation in the values of petal length among sample is more. Can you understand this with the help of this figure? Can you infer this? Hello? Hello?
Yes, sir.
Okay.
एक बार और बता दीजिए.
Then we also talk about scatter plots. So what is scatter plots? So basically, attributes value will determine the position, and you will plot two-dimensional scatter plots most often, but we also can plot three-dimensional. So we cannot plot four-dimensional scatter plot, because it will be difficult to analyze four variables data. Okay, and often we represent attribute values with the help of size, shape, and color. Okay, and I'll show with the help of an example. Okay, so see here, this is your scatter plot. So what is the scatter plot? What it is saying? It is showing the relationship in 150 samples, the relationship between petal width and sepal length. And these three colors are showing three different type of data set. What are those three types? One is your blue color is shown by setosa. Your green is shown, green plus symbol represent versicolor, while your red circle represents virginica. So this is showing a relationship between sepal length and sepal width, and you find that basically there is no relationship between sepal length and petal width. If you are increasing sepal length, petal width is not changing for all the three kinds of data in general. Okay. While in this case, you find it is showing the relationship between petal length and petal width. Can you see here? There is a linear relationship for all the three kinds of data. Okay. So as petal length increases, petal width also increases. Okay. As petal length of versicolor increases, petal width also increases. Okay. So through this box, you will be able to analyze the relationship between two variables. So there are since four variables. So this is showing relationship between petal width and sepal length, petal length and sepal length, sepal width and sepal length. Okay. While this is showing petal width versus sepal width, petal length versus sepal width, and this is your sepal length versus sepal width. Okay. And similarly others. Okay. Okay. So any query till now? Any query till now? Okay.
No, sir.
Now, then we also use contour plots. So let's see what is contour plots. Okay. So I had already shown, but now let's see what is contour plots. And it is useful when a continuous attribute is measured on a spatial grid, and they partition the region, okay, into similar values, and the contour lines that form the boundaries of these regions connected the equal values, means having same values will be joined together. So they will be showing with the same color, or they will be joined with the help of line. Okay. And you can show it that in the whole globe. Can you show the regions which has same temperature? Can you show the regions which has similar amount of rainfall? Can you show the regions which has similar kind of humidity, similar kind of pressure? Okay. Or can you show that is your economic wise, okay, that which countries are of similar in economic terms? Okay. So I have already shown this. So what you have done? So can you see that these regions which are shown in the red color, they have similar kind of temperature. Okay. And this temperature is around, you can say 27, 28. Okay. While this region, which is shown in yellow color, okay. Yeah. So they are having what? Similar kind of temperature, somewhere around 15. So you can interpret many things from this. What you can find, as you move away from the equator, temperature will be less. As you are closer to the equator, temperature will be more. Okay. Can you see this? And then the temperature distribution is approximately symmetrical. So if this is the equator, okay, then you find that the other side, the distribution is changing, the color is changing almost symmetrically. Okay. Now there is another way of visualization of the data. So what it shows, basically you have sepal length, and you have these three kinds of classes. So you want to see that how these the range of the data, what is the values, okay, what is the relationship between sepal length and the setosa, what is the relationship between sepal length and versicolor, what is the relationship between sepal length and virginica. I think you all will agree that we talk about some kind of correlation. So whenever there is increase in price of diesel, so the price of your potato increases, the price of onion increases. Do you agree? Do you agree that this kind of relationship exists? Okay. So you say there is a positive correlation. Then similarly, there is a negative correlation. What is seen is when a particular commodity is more in number, when particular your commodity is more in number, then the price of that commodity is less. So then we talk about there is negative correlation between the two random variables. So here you have computed some kind of correlation between virginica class data and sepal length. Okay. And similarly, your versicolor data and sepal length. And similarly, you are shown for other attributes also. Now, here what you are talking about, here you are talking about what is the relationship between setosa and virginica. So can you see that when you talk about samples of setosa and samples of virginica, so this blue color shows that the your correlation is very less, while red is showing that the correlation is more. So you find that there is more correlation between setosa sample and setosa samples. Okay. All right. So this tells you correlation between two random variables. For this problem, The random variables are setosa, versicolor, and virginical. Okay. Now, this I have already described what are the different kind of data types. Okay. Let's take the help of example. Okay. So let's say you have collected the data of cancer cases in US. So this is from 2001 data. Okay. And it was found. So this tabular form is giving you much better information than going through the whole data. So from the data, they have given a summarized information that basically there are 5 types of cancer cases in US during the period of 2001. And the number of colon cases were around 135,400, while breast cancer cases were around 193,700, prostate 198,100, and lung 169,500, and urinary is 87,500. So from this, what can you make out? That among these, first you have found one thing, that there are 5 kind of cancer cases exist in US in this data. What is the another information which you get from this data? You're finding that the number of cases of prostate is maximum. And the number of breast cases is second maximum. And the difference between breast cancer and prostate case is not much, is around 5,000. And the number of urinary cases is minimum among these 5. Can you interpret the data, the huge data like this? Hello?
Yes, sir.
Hello, do you
Yes, sir.
agree?
Yes,
Can you
sir.
get, let's say you are having so many records, but now you have summarized this information that you're telling what is the count of each one of the cancers. You are trying to see that there are only 5 different kind of cancerous disease in US, and you know what is the frequency of each one of them. So when you talk about this variable cancer, and these cancer can take 5 different values. So what you will say, this cancerous variable is categorical or continuous? Who will tell? Is continuous or categorical? Hello. Cancerous, type of cancerous, they are taking, it is taking 5 different values. So will you describe it's categorical or continuous?
Sir, categorical.
Categorical.
Categorical, you're right. Good. Okay. Then can you order them? Can you order colon, breast cancer, or urinary cancer? Can you give some order? Will you say this categorical variable is ordered or unordered?
Unordered.
Will you say it is
Yes,
ordered
we
or
may.
unordered?
Unordered.
Right, good. Okay, it is unordered. Why? Because I cannot say colon is less than breast. I cannot say colon is less than urinary. I cannot say colon is less than prostate. Okay. In terms of number, we can define, but I'm talking about type of. So this type of disease, colon and breast cancer disease, I cannot compare the two. These two are 2 different diseases. That's all. Okay. So we cannot order them. Okay. Then if you, from the same data, now what I can do? These are the total number of samples suffering from these different kind of cancers disease. And if you want to find out what is the percentage of the people suffering from this colon, so we say it is 17.26%. Breast 24.70%. Prostate 25.26%. Similarly, lung and urinary. Okay, so total is your 100%. So this we say your frequency table. Then, so I could have shown this data as a histogram also. Okay. So this will give you a graphically, you can see one was your tabular form and this is your graphical. So easily you can see that breast cancer and prostate cases are nearly equal and they are having maximum number of cases, and urinary is having minimum number of cases. Now, so if sometimes you are given the data, okay, so then what you do for better analysis of the data, you divide this ages into many groups. So you can make age groups like this. That is okay. 20 to 25, 25 to 30, 30 to 35, 35 to 40, and then you find out that what is the frequency of each one of the groups. In this particular case, what we have done, we have created group of size 10. Okay, and based on this grouping, we can say what? That in this 21 to 30, how many cases are there? So only 2. 31 to 44, 41 to 53, 51 to 61. So again, this can be shown in terms of histogram, okay, or relative frequencies. So what is histogram? Is a bar chart constructed using the frequencies or relative frequencies of a grouped continuous variable, okay? And using this, we can discard some of the information and we can retain only relevant one. Okay. So, these are the data related to your leukemia, 10 adult leukemia cases. Means there is a data of 10 who are suffering from leukemia, and you want to find out what is their age group. Okay. So now, after going brief details of EDA, that is the exploratory data analytics. So what can be done? Okay, so I am going to explain with the help of some of the examples. Okay, so what usually is that when you do data analytics, you develop a decision model, predictive models. What is the first thing you do? First thing you do is you have to do a data collection. And for data collection, then you decide what are going to be the attributes which you are going to consider while collecting the information. So this is the data which has been collected from the Places Rated Almanac were in the 1985. And this data is from 329 metropolitan areas of USA. And this is describing in terms of 9 variables. So what are those 9 variables? What is the climate mildness? What is the housing cost of each one of the metropolitan areas? There are 329 metropolitan areas, and each one of the metropolitan areas is described in terms of 9 variables. So climate mildness, housing cost, what is the conditions of healthcare and environment, what is the crime rate, what is the transportation supply, educational opportunities and effort, arts and culture facilities, recreational opportunities, personal economic outlook, and or you could have thought of computing few things also, latitude, longitudes, okay, and many more things. Okay, and then once you have collected the data, then it is important that you dig into this data and you do your exploratory data analysis to find out that among these 9 attributes, which attributes are relevant for your problem for analysis. You may find that, let's say, housing cost is almost same in all the 329 metropolitan areas. So then there is no point you use this variable, because this is almost same. You would like to see variability, that among these 329 metropolitan regions, what are the factors because of which the condition of one metropolitan area is different. Okay, so what can be the questions? How is climate related to location? Means, does climate depends on the location? So are there clusters in the data? Clusters means similar kind of data. Similar in terms of crime rate, similar in terms of climate, similar in terms of housing cost, similar in terms of transportation, similar in terms of educational opportunities, okay, or personal economic. So you want to do clustering. Are nearby cities similar? So you can plot it. Okay. Just the way we have plotted your temperature, okay, of the whole world. So we can plot, and through that we can analyze whether the nearby cities have the similar kind of climate, similar kind of housing costs, similar kind of healthcare, crime. Okay. And then any relationship between any two attribute. Okay. So that we can do using a scatter plot. Okay. And so what we can do, so let's say one relationship, what we can do, is there any relationship between economic outlook and crime? And similarly, you can think about other questions. And then based on this, you would like to do, you'll use different kind of summarized and graphical tools for analyzing the data. Let's say you talk about another example. Let's say in a breast cancer research, main questions of interest might be what? Does any treatment method result in a higher survival rate? Means which treatment will provide more longevity? Can a particular treatment be suggested to a woman with a specific characteristic? So is there any difference between patient in terms of survival rates? So are white women more likely to survive compared to the black woman if they are both at the same stage of disease? What is the probability that at stage 1 a person can live for longer life, or longer than 70 years, longer than 80 years? So you can think about and then analyzing such kind of things from once you have collected the data. Let's take another example. Okay, so let's say that you have a project and investigating the well-being of teenagers after an economic hardship. So these days there is a lot of economic of many countries, economic condition is not good. So what can be the question? So after taking the data, so what are the important factors because of that the economic hardship is faced by the countries? Which countries are facing more hardship? What are the factors? Okay, are these countries which are having hardship, they are in the nearby location? Okay, so you see that because of the this ongoing war between Russia and Ukraine, you find that there are economic conditions of many countries is not good. Because of your COVID-19, you have seen that the economic conditions of many of the people have deteriorated. Okay, so what are those factors? Which other factors can be most related to distress of teenagers? You can analyze age-wise, gender-wise. Okay, you can analyze reason-wise. You can analyze for private schools, government schools. Okay. So I think I'll stop here. Okay, let's have some questions from the audience. So do you have any questions? We'll do our lab sessions so that you have better understanding of this. But prior to this, whatever we have discussed, do you have any query? Any query? No query. So what to do? Should we start your some practical sessions right now itself? Hello. Where is Dr. Kusum? Dr. Kusum? Dr. Kusum.
Good evening, sir. Hello. Hello.
Hello.
Good evening, sir. I am from Asia Connect site. Sir, for wait a minute, ma'am will join.
So if many of you are saying that we can start with your practical sessions, huh? Okay. Okay, so let me start. What I can do initially, we can do in this half, we can do only descriptive analysis. Okay. And then later on, we can talk about graphical methods in the last class. So would you like to do implementation also parallelly? Hello. Would you like to do implementation parallelly yourself?
Yes, you can go with that.
Okay. Okay. So then in that case, what I suggest, all of you can open Google Colab. Kusum.
Yes,
Kusum?
yes, sir. Yes, sir.
Dr. Kusum.
Yes, sir.
Dr. Kusum.
Yes, sir. Am I not
हाँ,
audible?
आपकी आवाज थोड़ी सी धीरे आ रही है. What
अच्छा.
I'm saying that I thought of giving around 15 minutes time for questions. Okay. And there is no question from the audience. So in that case, what I can do, I can introduce some basics of your practical before, I think that because our session is up to 4:30. Okay. 2:30
Yes,
to
sir.
4:30. So I will have some hands-on on the basics of descriptive analysis or summarized analysis. So I request all of you that you open a Google Colab. Okay. So once you are able to open, then you tell me that then I'll start showing you demonstration. Or let's say that first of all, I discuss PPTs and then I'll do implementation part. Okay. I think, is it visible? Is this visible to all of you?
Yes, sir. It's visible.
Okay. So I'm going to show this exploratory data analysis using Python. So when we want for data analytics, so you'll find that these are the main important Python toolboxes or libraries. And one of them is NumPy. Okay. And this NumPy is specifically, I'll describe why we use NumPy, then SciPy, Pandas, and SCI KIT Lang. Okay. And for visualization libraries, you have Matplotlib and Seaborn. So Seaborn is basically extension of Matplotlib. So what is NumPy? NumPy introduces objects for multi-dimensional arrays and matrices. Means the data will be stored in terms of arrays or matrices. Okay, first point is that your all samples will be stored in terms of arrays or multi-dimensional matrices. And it provides functions that allows you to perform advanced mathematical and statistical operation on these data. Okay. So what is NumPy? Basically, it stores the data. It allows you to store the data in multi-dimensional arrays and matrices, and also provide you functions that allows you to perform some advanced mathematical and statistical operation. Okay. And other important point is, that is, it provides vectorization of mathematical operators on arrays and matrices, so which significantly improves the performance. So let me make you understand this. Let's say if I want to add two matrices of size 5 by 5. So what we can do? We can add element wise. We can write for loop for I is equal to 1 to 5, for j is equal to 1 to 5. Okay, Cij is equal to Aij plus Bij. So then the coding of the code looks little bigger. Okay. And sometimes when the code is bigger, it is difficult to understand what is happening. And then it takes more computation time also when the length of the code is more. But you will find that here you can add two matrices. You can simply write down this a matrix A, this matrix B. You will simply write down A plus B. There is no need of writing for I is equal to 1 to 5, for j is equal to 1 to 5, Cij is equal to Aij plus Bij. Have you understood? Hello, have you understood this part?
Yes, sir.
Have you understood? Okay, so let me take another example. Let's say you want to multiply two matrices. Let's say there is a matrix A of size 5 by 10. There is a B matrix of size 10 by 5. And you want to multiply and store in C. So then what we do? We'll write down a code for I is equal to 1 to 5, for j is equal to 1 to 5, for k is equal to 1 to 10, Cij is equal to Cij plus Aik into Bkj. So you find that you're writing more number of codes. While you are implementing also, this will take more computation time. Okay, but here what we can do, simply we write down C is equal to A into B, or product of A into B. That's all. So can you see that you have reduces the size of the code, and at the same time you have also reduced the computation time. Okay, have you understood this part? Have you understood this part? Why vectorization of operation, vectorization of mathematical operation on arrays and matrices will improve the performance? Have you understood this part?
Yes, sir.
Okay, good. Okay.
Sir, how computation will be decreased?
And there are many Python libraries which are actually built on NumPy. So I can say that NumPy is a primitive tool which is used for data analysis. Now there is another toolbox which we say SciPy, SciPy. So it provides you a collection of methods for linear algebra, for differential equations, for numerical integrations, for optimization, for statistics and more. Okay. And this is also built on NumPy. Then there is another toolbox or libraries which we talk about pandas. So pandas provides data structure and tools which are specifically designed to work with table-like data. Okay. Okay. So there are many powerful operations are defined which can work on your table-like data. Okay. And generally, when we talk about your exploratory data analytics, so our data will be most of the time will be in the form of tabular form. Okay. So it provides tools for data manipulation, like reshaping of the data, merging of the two data, sorting of the data, slicing of the data, aggregation of the data. Okay. And it also allows handling missing values. Okay, because sometimes while somebody is collecting the data, it's possible that he forget to write one value for one particular attribute, or that attribute was not readily available at that moment of time. So before you start analyzing the data, how you can handle missing data. Then you have another toolbox which are used for data science, which we say SCI kit learn. And basically, this will allow you to develop decision model or predictive models using machine learning algorithms, say for classification, for regression, for clustering, for model validation. And this SCI KIT learn is also built on the top of NumPy, SCI Py, and Matplotlib. So while we'll be doing experimentation, okay, implementation, so I'll be using this also, Matplotlib. Okay. So there is one software which you talk about, MATLAB, which is a very powerful tool or app, okay, and which provide you different kind of graphical features. So Matplotlib provides many functionalities, many libraries, so that the power of is very much similar to MATLAB, which allows to reproduce quality figures in a variety of hard copy formats. Okay, so using Matplotlib, you will see we can plot line plot, scatter plot, bar chart, histogram, and many more. Okay, and this is relatively low level programming tool. Okay. Then there is another toolbox which you talk about, Seaborn. It is based on Matplotlib, and it provides high-level interface for drawing attractive statistical graphics. Okay, and this style is very much similar to ggplot2 library available in R. R is again you can say open software. Okay, for data analysis. Okay. So as I said, NumPy and pandas are going to be very, very important thing. So before we start processing anything, you'll find that we are going to import this NumPy and pandas. So when I say import NumPy as NP, means you are going to create an instance of NumPy and you are naming this as NP. Okay. And similarly, you are going to create an instance of pandas, which we are naming as PT. Okay. Yes, one of you is asking, is MATLAB free like R? So no, MATLAB is not free. It is a costly software. Okay. Okay. So what I can do? I can do the following. When you have to read data, okay, so your data can be in Excel file or Word file or text file, or it can be image, it can be audio file, MRI file. So you can read this data. So how you can read the data using Python package? So first we import the Python package as we are going to use it. So I told that we are going to create an instance of NumPy and pandas. So it is this. Okay. So there is Irish data, and the location of this Irish data is basically it is available in UCI repository. Okay. So this is the path where this data is located. So I'm this is the path. So I'm writing path where this Irish data is there. So I have defined this path. Then, as I told you that this Irish data is described in terms of these four features: sepal length, sepal width, petal length, petal width. And then it is associated one of the three kind of species. Either it can be Setosa or versicolor or virginica. I have already said that this data contains 150 samples. And each sample is described in terms of these four features. in terms of centimeter. And these samples can be belonging to one of the three categories. First 50 samples belongs to setosa, and next 50 samples belongs to versicolor, and next 50 samples belong to virginica. So using the instance of pandas PD, since this is a CSV file, so there is a function read_CSV. I give the path where this file is there, and then what are the name of the fields, because in this CSV file the name is not available. Okay, so that I give name also, and after this then I can see what is this data. Okay, so I think I'm stopping it here. Okay, and we will carry on the implementation of this after half an hour. Is it fine? So you can have a break for half an hour, and then we can start, and we join again at the time 5 p.m. Okay. But if you have any query, I can take up your queries. Okay, so that we can do implementation at one go. Okay. Are you getting things? Hello, are you getting things?
Yes, sir.
Yes,
Okay.
sir.
So I think with implementation, your clarity will be more. Okay. So in